Okay, everybody, I've got my two physical models here. I've got a hard cube, and it's just made out of plexiglass. So it's just a hard cube, and it's got the paper still on the sides. I just didn't pull those off. I didn't think that was necessary, but anyway, you can tell that that is hard. And then in this is called Silly Putty, and I'll open up the container, and inside is just what we call a soft solid. And so I'm going to do a couple things just to compare the two, okay? The first one is you will see that just observing them, not moving them, not manipulating them, I can tell they're a solid because they have the characteristics of a solid. In other words, they do not take the shape of the container. So right now I don't have a container that they're in, but they're sitting on my table. So if this was a liquid, they would take the shape of the tabletop, and they're not. They're hanging on to their own shape. The other thing I can do is I can try to change the shape, okay? So with the hard solid, I'm gonna squeeze it all different directions. I'm applying a lot of pressure. It is not changing, okay? So I'm gonna do the same thing with the Silly Putty, and I have to apply a lot of pressure, but you can see that I can change the shape. This character trait is called malleable. Malleable just means that it can change, like I can make it flat. That you can push something or press it so that it is flat. Okay, and that's definitely flat. However, I can, when I leave it alone, it will retain the shape. So it is a solid. So when we're talking about how to consider these models, when we're trying to understand what the mantle is like, the mantle is like this soft solid. It changes shape. So if we had a hard solid on top of this, like the hard solid rock of Earth's crust, you can see how Earth's crust could move as that soft solid rock underneath it moves. Okay?